This is TWIS, This Week in Science interview episode. Interview with Dr. Moiya McTier. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Hey everyone, I'm Dr. Kiki, and today on the show we are going to be speaking with Dr. Moiya McTier about her new book, Milky Way. And it is an autobiography of our galaxy, not the autobiography, an autobiography. So I guess that the Milky Way has written several or may write more. We'll see about that. I would love to introduce my guest for today. Dr. McTier has a degree in astronomy, mythology, PhD in astrophysics from Columbia University, and she is also a folklorist and science communicator. Welcome to the show, Dr. McTier.
Thank you so much for having me. Dr. McTier is my mom, so you can call me Moiya.
All right. So you're not grabbing onto the doctor title at this point.
I mean, it depends on the context, right?
Yeah.
Sometimes I don't want to be that formal, but I like the sound of Dr. Moiya. Like it sounds nice.
I go with Dr. Kiki. So, Dr.
Yeah,
Moiya, here you are.
thank you.
Thanks for joining me today. And just to get started, the background mixing mythology, folklore, and astrophysics. I mean, this, at least astronomy kind of goes back into that mythology, folklore,
Yeah.
human cultural history for, ages. But how did you come to bring it together?
Yeah, I don't know much about astrology.
Yeah.
I I put that out there because often people hear I'm an astronomer and they get the two confused, so they start asking me about zodiac signs, and I'm like, sorry, I am not the right person for this. That is one of the default assumptions that people have when they hear I did astronomy and folklore together. A lot of people assume that I would study constellations. I did propose a few different projects when I was an undergrad, maybe looking at creation myths from different cultures and seeing how those compare to the Big Bang Theory. What I eventually ended up doing was researching an exoplanet from with data from the Kepler spacecraft, and then I wrote a science fiction novel that was set on that planet and was inspired by the Hawaiian sovereignty movement. So I have had this weird circuitous journey to try and connect these two, and now most of the way that I do that is through fictional world building, using science and facts as a building block.
And as a world builder, what are your favorite kinds of worlds to build? Are they
Hmm.
realistic? Like how do you go about deciding, okay,
Yeah.
this is how my world is going to be?
I love this question. I have really honed my process for building a fictional world over the last few years, and it starts with your intention. What do you want to do with this world? Do you want to tell a story in it? Do you want to play a game in it so that it's interactive? Or are you just trying to build a place where you feel like cozy and warm for yourself? I often do world building as an escape exercise. So I teach people science so that they can make their worlds feel rich and textured and realistic, but it doesn't have to be solely based on science for something to feel real. I really love fantasy worlds. We don't have magic on Earth the way that they do in a world with fairies or dragons, but you can still make something. Actually, I'm gonna not use the word realistic. I think coherent is what
Yeah.
I want in a world. Something that
Okay.
just sets rules and then follows them throughout.
Yeah, that internal consistency is
Exactly.
very, very important. And I find myself when I'm reading science fiction or fantasy that when the world breaks its own rules, I get really mad.
Mhm. Yeah, it can totally take you out of the experience and make you not wanna keep reading or watching it anymore. I've had that experience several times.
So the difference between your previous book, Lying Hordes,
Mhm.
about the exoplanet that you were studying, how did you make up physics for this exoplanet? Did you make up
Mhm.
any rules for the chemistry and the life that would be there? Or was this all, was everything based on hard science in your exploration of that world?
Yeah, I love that. As much as possible was based on the hard science. The the tricky thing with saying, uh a planet out there is habitable is that we don't have the information available yet. We don't have the technology to give us the information necessary to say whether or not a planet is Earth-like and habitable. So the only thing I really knew about that planet was how big it is approximately and how far away it was from its host star, which gave me an idea of what temperature it might have. But I knew nothing about its atmosphere, nothing about its surface. So all of that had to be made up. And what I ended up doing was saying all of the things that I don't know about this planet through the data, I'm going to say that they are pretty similar to Earth. So it had an Earth-ish atmosphere. The chemistry, the physics were pretty much the same. I think the gravity was maybe slightly different. The biggest difference between that world and Earth was that it orbits a very different type of star, one that is dimmer and cooler than our sun.
So it would have been, so this exoplanet itself is closer to the sun. It had its habitable zone is totally different.
Yes, you
Yeah.
know. So
Yeah.
it's
Tell
actually
us
it
a bit
was
about like what you learned through your graduate work that kind of
yeah.
became the nugget.
Okay. So that world, it was much closer to its star because the star was cooler than our
Mhm.
sun, but it was so close that it we think that it might have been tidally locked, which means one side of the planet is always facing the star. So you have a day side of the planet and a night side. And actually, one of the big struggles in that book, one of the big conflicts was that they knew their planet was becoming tidally locked and needed to get off of it onto another planet in their system that was further away. So that was really fun to think about. And then when I went to graduate school, because that was my undergraduate work, when I went to graduate school, I started exploring different facets of exoplanet habitability. I knew that I was really interested in galactic habitable zones, so where in the Milky Way galaxy do we expect to find the right conditions for life? And I had a great time answering that question. My first project in grad school was trying to come up with a method to find mountains on exoplanets and quantify how bumpy those planets were. Because if we know that a planet has mountains or other topographical features, then that gives us insight into the interior of the planet, which we don't have other ways to do right now. And then I did a couple of projects looking at the motion of stars around the galaxy and how that affects planets. So one was, are fast stars more or less likely to have planets around them? And it
Hmm.
looks like, oh, do you have a guess, actually? I want to ask.
Yeah, I was sitting and thinking about that. So by fast stars, do you mean stars that orbit more quickly or that are spinning themselves more quickly?
Great question. Orbit around the galaxy.
Hmm. Hmm. This I'm gonna say less likely.
Okay. It turns out that there's not really an effect until you get to really high velocities of stars in the center of the galaxy. But out here, where we are in the disk of the Milky Way, there's not much of an effect. But then I took my conclusion from that paper, and my next paper looked at the center of the galaxy and simulated the orbits of stars in what we call the bulge, which is this much denser region of the Milky Way.
Mhm.
And I was trying to see how common stellar flybys are. How often do stars have these gravitational interactions? And I found that they're pretty common in the bulge. 4/5 of stars can expect to have a close gravitational encounter. And then I took that information and did another project on how can we look at clumps of stars, and we call them moving groups. They're stars that are not actually clumped in physical space, but they have similar velocities, like they're moving to
Mhm.
together. And I did a project to look at their chemistry to see if I could backtrack how those moving groups formed. So, yeah, I did a lot of fun stuff in grad school.
That I mean, it sounds so interesting coming to this, the origins of different aspects of the Milky Way. So, like the moving groups, did they all form
Mhm.
together? And if they did form together, would they have similar composition? And or you would
Yeah.
assume that they would. And
It depends on how they form. Like, it was like a mystery that I got to solve.
and all of the work that you've been involved in, how is this going to impact our view of the Milky Way moving forward?
That's a
Does it?
great question. I think that my research added some information about where we might expect to find life like us.
Mhm.
Although I take the view that life is probably pretty common in the universe, and if it is, then it's going to adapt to the environment that it's in. So most life won't look anything like us because most
Mhm.
planets don't look anything like Earth. So it was definitely poking at the anthropological principle when we're like anthropomorphizing everything and putting humanness into everything that we're looking for.
Yeah,
But I do think
and when you say life,
right.
microbial, like some
Anything.
anything, right?
Honestly, at
Yeah.
this point, astronomers are looking for anything that reproduces and ingests fuel, because the definition of life is
Yeah.
pretty, ambiguous. I do think that
Yeah.
my science communication work will have a much bigger impact when it comes to changing the way humans see the galaxy. And you can see that in the book. What I really want people to do is stop thinking of space as something separate from us. We are on a spaceship right now. Earth is a spaceship traveling through the universe. We are a part of space, and I want people to stop separating us.
I mean, very similar to how historically we've tried to separate ourselves from nature, from
Yes.
the animal kingdom and, oh, we're above it somehow and
Right.
different. And yeah, we're a part of all of it. Yeah.
Exactly.
Yeah.
Yeah.
So, and this is where the storytelling comes into play and really makes a difference. And so I'd love to know your graduate work and looking at the Milky Way. Were you weaving stories about the Milky Way from the Milky Way's
Mhm.
perspective the whole time? Were you asking the Milky Way these questions,
No, I
hoping for an answer?
I mean, that's kind of what all astronomers are doing is,
Yeah.
spending hours with data that the universe has kind of gifted to us and trying to eke out an answer.
Yeah.
But no, I think this project that I did, anthropomorphizing the galaxy and giving it a personality, that was a recent project that I wasn't always doing. It was fun, though. It was really fun to try and get myself in the mindset of this 13 billion-year-old, like 100,000 light year across thing. It was really fun to do that.
And from the get go in the book, it's the Milky Way has got sass. The Milky Way is like, oh, puny little humans, you're nice. I'm glad you happened, but
Yes.
whatever,
One of my favorite reviews of the book so far has said, "The Milky Way is such a jerk. I don't know how it got this book deal or why someone as nice as Moya agreed to write it for the Milky Way, but the Milky Way's a jerk and I want out."
But, that's our human anthropocentric perspective, right?
Yeah.
We are, you want the universe to be nice to us, right? Oh, treat us nicely. Let humanity
Oh, we're
live.
so special.
We're special. Yeah. So, from the perspective of a conscious galactic entity, this universe, it's talking to its cells, but at the same time, it doesn't have to coddle those cells because
Right.
what's going on there? I'm so much bigger than you. Like it's not being a jerk. The attitude is I mean, I don't know. I've considered books on AI
Mhm.
and consciousnesses before, superhuman consciousnesses, and
Yeah.
why would they be nice to us?
Exactly. The Milky Way, like, we are such a tiny part of it. The fact that it is speaking to us at all is it being nice. One of my friends, when she read the book, was surprised because she thought it would have more of a nurturing mother nature type of personality. I was like, well, why would it? I mean, the earth, I can see the earth having more of a nurturing mother nature personality. It deals with us all the time, but
Yeah.
the Milky Way, we've been around for such a tiny fraction of its lifespan. Like why would it give us that respect?
And I mean, really, it's like watching a little bit of mold grow in, in your bathroom. You're like, you notice it and you go, huh, is that good or bad? Yeah.
Right. Yeah, at one point in the book, the Milky Way compares the human lifespan to that of a mayfly. And it's like this fly spends its entire life in one room of your houses. Like, do you ever wonder why it bothers to do anything at all? Because that's how I, the Milky Way, feel about you humans. Like, why do you bother? You live for no time. So it does respect us in that way. It admires our grit and determination.
Yeah. So tell me, this old, snarky, sassy Milky Way. Who does the Milky Way want to be talking to? Who is it trying to reach out to?
It's trying to reach out to all humans. I mean, it sees us all
Yeah.
as the same, right?
Yeah.
There's a line in the book where it says that the idea that there are different types of humans is utterly absurd to the galaxy. Like, we all look the same to it. But really, it just wants us to start telling stories about it again. The reason that the
Mhm.
Milky Way decided to write its autobiography is because for most of its existence, it has been pretty lonely. And much of what it does is destroy. I mean, it forms stars, it falls in love with those stars, and then has to reckon with their inevitable demise. And that
Mhm.
has created a lot of inner turmoil for the galaxy. So when humans came along and we started looking up at the sky and using it to keep time or navigate or entertain ourselves in our little communities, it felt useful and it really liked that feeling. But then we stopped, and it's almost like it got this brief flash of positive emotion, and then we took that away. So now it is trying to get us humans to be more familiar with space, which is hard because most people don't have a good view of the night sky. We don't need to rely on it to navigate or keep time, and even entertain ourselves. We have Netflix now. So, yeah, the Milky Way is speaking to all of us.
And you've talked about the fact that you grew up uh, out in the woods where there was no television. You weren't connected in the
Mhm.
way that people are connected so much around the world now, looking at our devices. And even in your life now, do you see this, I guess, belly button gazing, navel gazing of humanity? Is it going to affect astrophysics? Do you think that we
Ooh.
will have fewer people looking up at the sky to ask questions, or do you think they're going to be finding all this stuff on the internet? Because
Ooh, that's a great question. I could see it going either way,
yeah.
actually. We have more technology now than we ever had to observe the universe and share what we learn about it. So there is a big mis and disinformation problem with the internet, but it's also a really powerful tool to get cool knowledge and information out there. So I
Yeah.
think I was really hopeful when I saw the response to the JWST images, people immediately downloading that picture of the Ring Nebula and putting it as the screensaver on their phone. I think that's awesome. If that's the way that we can connect to space now, then okay, let's
Yeah.
really lean into that.
Yeah, let's lean into, I mean, the speaking of the JWST, I mean, there's some amazing stuff that's going to allow us to look at exoplanets, to be looking at our neighbors,
Yeah, I mean, people got super excited about the images, and I get it. We're a visual species.
Yeah.
The Milky Way also thinks that we're we're silly for relying so much on our sight, but I was really thrilled by the spectrum that we got with JWST of one of these big Jupiter-like planets. We saw such a clean spectrum, which tells us what elements are present in this planet's atmosphere. We saw signatures of water in this planet's atmosphere that would be impossible to see with any other telescope. So yeah, it's amazing what JWST can do.
There's been a scientist who has been putting out his ideas. I think he has a book coming out in a little bit, that because of JWST, we're going to be seeing that inflation isn't happening and that the Big Bang didn't happen, and that the JWST is going to give us the evidence to put the Big Bang theory to rest.
Yeah, I got a question about this last night at an event, and I hadn't heard about it. I need to look this up after this. I'm
Yeah.
I'm wondering what is it, it's the expansion part. Do they think that there's no expansion or that the expansion isn't accelerating?
No, I think it's the
Oh, so
inflationary
backwards.
part. Yeah. Backwards.
Fascinating.
Yeah.
I'm gonna look this up
I mean,
after our talk.
yeah, it's interesting, but I'm like, okay,
I mean
PR
that
for it's one of the fringer ideas, but they're saying this is new evidence that the JWST is bringing out. But
right. I mean,
we'll
as
see.
scientists, we have to be open to new evidence giving us kind of paradigm shifting information about the
Yeah.
universe. 100 years ago, it was paradigm shifting that the universe was expanding and not just standing still. And then it was another radical shift to say that that expansion is speeding up. So yeah,
Yeah.
I'm ready for my mind to be blown, but I would need a lot of evidence to be blown.
Yeah, the extraordinary claims rely
Yeah, we need
require
extraordinary
extraordinary
evidence.
evidence.
Yeah, I mean the inflation thing is interesting because there's so much in our Big Bang hypothesis, our Big Bang theory that says like we didn't have all of the data available at the time, and so there are a lot of aspects of it that are kind of like, well, we need this to happen to explain other things. And so the inflation part is kind of a weaker point of the Big Bang theory, where we needed the universe to get really big all of a sudden, and so we were like, oh well, what if it just inflated to thousands of times its original size? And so like, yeah, I'm ready for that to be questioned.
Yeah, and if we can make it more accurate, that's
Yeah,
a big part of it.
exactly.
But from inflation back to your book about the Milky Way. I don't want to get off track too much. These questions, astrophysics is a huge field. It's very
Maybe the
large.
biggest field.
How does the Milky Way feel about its place in the universe?
Really good.
Yeah.
Really good about it. The Milky Way has a lot of confidence, but it's not unearned. The Milky Way is the biggest, strongest galaxy in the local group. That's the small neighborhood of about 50 galaxies that we've discovered. Andromeda is the other biggest galaxy in the group. It's unclear which is more massive and which has more stars. The measurements keep going back and forth. But the Milky Way, for a long time, really hated itself and and really felt guilty for not being able to make a star that didn't die. But then it learned how to fight back and talk back to that voice whispering these horrible thoughts in its head. And part of what brought it out of that was its love for the Andromeda galaxy. But another part is just taking a moment to really step back and look at what it's doing, look at the effect that it has on the world around it. And when it did that, it was like, oh wait, no, I'm awesome, I'm beautiful, I'm strong, I'm brilliant, I'm the Milky Way, like everyone should love me. So the Milky Way feels really good about its place in the universe, even though it knows that there are other bigger galaxies out there.
Yeah, and this is a lesson that maybe individuals can take from this perspective that the Milky Way has taken about itself.
That's the point.
Yeah. Um, you know,
You
I don't
can
think
you can absolutely see that I wrote this book during the pandemic at a time when I and many others were struggling with mental health.
Yeah. Okay.
Mhm.
That in itself is also, an interesting weave, weft to the weave. Um,
Ooh, yes.
so as we come into the end of our 30 minutes here, what are what are a few of the things that you really need or want people to know about your book and what you've put into the world?
Hmm. You do not need to know any astronomy to pick up this book and learn from it. It is written not for children. I do not do any of my work for young audiences. It's written for like I'd say high school and up, but you do not need to know any astronomy. Every time there's a new term or a piece of jargon, I do explain it in the book. Um, I think you'll also find that it's not just about astronomy. There are myths in here, stories and folklore that we have made about the Milky Way galaxy throughout human history. There is also history of science in here where you can learn about how astronomers and physicists and other researchers learned what we do. Because I've found in my science communication work that so much of SciComm is just giving people scientific results and hoping that that it sticks in people's minds. I think it's a lot more effective if you teach people how the science is done. So you'll find that in this book too. I mean, the advice that you get when you write a book is not to say that you are writing this book for everyone, but I really do feel like there's something in this book for everyone.
What did you gain from writing this book?
Confidence. I did not think I could write this book. I didn't. I didn't think I had enough to say about space. I didn't really trust myself to pull off the conceit of writing from the perspective of an omniscient galaxy because I do not know everything. And actually I'm still terrified that there are wrong things in this book because the publisher does not have anything to do with fact checking. Like I had to send this book out to my astronomy colleagues to get it fact checked myself. So I'm still worried, but I am so much more confident in my ability to write and communicate and express complex ideas now than I was before this project.
Yeah, and it's all this kind of a project I can imagine. It's always in science, it's what we know now. There
Yes.
are always more questions being asked and more technologies coming forward to help us answer questions more accurately and
Mhm.
more efficiently. But yeah, I think that's in scientific training. We're trained to not ever really conclude anything. There are
We've constrained
implications
the
of your data.
possibilities.
Yeah, the universe is probabilities. This is it.
Yeah.
It's all
Yeah.
statistics. So how can I ever be certain? And how can you write a book with error bars?
But it's also like we have made discoveries since I've finished writing this book. In the book, I talk about the image that we took of M87's event horizon. This is the edge of a black hole around another galaxy. And I had this quippy little line about how, oh, you humans, your eyesight is too bad to see the black hole at my center. And then, like literally less than a month after I turned in the final version, we had taken that picture of Sagittarius A star, and I was like, you couldn't have analyzed your data just a little bit more quickly.
Yeah. Come
Come
on.
on. But that's okay. That's what like future updated releases are for, or a
And
next
maybe
book.
or next book, yeah, when the Milky Way gets to more specific navel gazing. I don't
Yes.
know.
When the Milky Way finally becomes the celebrity to humans that it feels it should be, then then there won't be another book.
Well, I am so glad that you have written this story, this autobiography of the Milky Way, so we can get a look inside the Milky Way's inner life and
Yeah.
thoughts.
Thanks.
And hopefully it will lead more people and, in the way that Carl Sagan, began so much storytelling in the scientific, or not
Mhm.
began, but really inspired so much storytelling in the scientific sphere. I hope that this does that as well.
Aw, thank you so much. Me too.
Yeah. Where can people find you online and where is this book available?
This book is available anywhere books are sold in the US, and there will be different translations coming out over the next couple years. You can find, there's also an audiobook that I read, so you can hear me talking as the galaxy. And you can find me on Twitter, Instagram, and TikTok. I finally took that plunge at Go Astromo. It's the same on all platforms.
Fantastic. And thank you for taking on all the different social medias. None of that is easy.
No. And it's like you post different things on each of them because you have a different persona across them. It's interesting. I'm still learning.
Well, if you wanted places for world building, you've got them.
Oh,
all
yes.
sorts of outlets, different personalities. It's going to
Yeah.
be fabulous. Thank you so much for joining me. I am very, very glad I got this chance to talk with you, Moiya.
Yeah, me too. Thanks, Dr. Kiki.
Thank you, Dr. Moiya. And I hope everyone out there has enjoyed this interview. Thank you for joining me for this conversation. And we will return next Wednesday at 8 p.m. Pacific time for our regularly scheduled live streams. And in the meantime, remember, it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.